All right, let's see how you did. So we're going to go back up to question number 1. We're going to start with the principal that's given. Convert our percent to a decimal. This is multiplied by 1 year's time. We should have got 390. Next question, 23,000. Convert this 1.9% to a decimal. Remember to be careful here. It's 0.019 times 60 months. So 60 months equals 5 years. So you could put 5 years or you could put 60 over 12. Both will work. Put that in your calculator. You should get 2,185. Next one. 1,800 times converting 0.13. So our rate is going to be 0.13 times 3 years. Put that in our calculator. 702. And the last one in question number 1. 13,600 times, convert this percent to a decimal, 0.059. 0.059 times 9 over 12. Then our calculator, you should get 601.80. All right. Hopefully you guys did well on that. We're going to move down to ordinary and exact interest. Okay, so you have ordinary again, and you have exact interest. So let's start with ordinary. Remember, ordinary is on this 360-day model. Question 2 is 45,000. Converting this to a decimal, 0.12 times 120 days over 360 because it's ordinary. Put in your calculator, you should get 1,800. Our last example here in question 2 is 7,150. Convert my percent to a decimal. It's times 0.10 times, again, 270 days over 360. Ordinary interest gives us 536.25. All right, so that's ordinary. We'll go down to exact, and then we'll answer question number 4, and that will conclude simple interest. All right, so now we're doing exact interest, and that's that 365-day model. All right, question number 2 is 45,000 times 12% converted to a decimal is 0.12 times 120 days over 365 because it's exact. Put it in our calculator, you get 1,775.34. And the last question, 7,150 times 10% converted, 0.10 times 270 days over 365. Put in your calculator, 528.90. All right, just going back and repeating what we said earlier, you notice the difference between ordinary and exact here because all of these principles, rates, and times are the same. The only thing different between question 2 and 3 is the model that's being used. In question 2, it's a 360-day model of ordinary interest. And in question 3, it's an exact interest, which is using the 365-day model. And again, like we said before, ordinary interest is going to be higher. So if you look at ordinary interest, it is higher than the exact interest below. All right, now let's finish up with number 4. Sue needs to borrow $20,000 from the bank to buy a new car. She has 2 options for her loan. One loan has an interest rate of 2.9% for 36 months. The other has an interest rate of 3.9 for 48 months. Which option will she pay less? And how much less will she pay? So we got a couple of things going on here. We got to figure out which one is better and which one is going to, in the end, how much is she going to save? So we have option number 1 is in yellow. So we're going to say option number 1, option number 2. Okay. So you have yellow and you have blue. Again, we're still using the same formula that we used before. So it's I equals P times R times T. So I equals P times R times T. In the first one, we are looking for our P, and our P is going to be 20,000 in both. So 20,000 times R, which is right here. 2.9% converted to a decimal becomes 0.029, and 36 months, 36 over 12 equals 1,740. Now, the 36 months, some people might have recognized that as 3 years, and you could have just multiplied it by 3. That would have given you the same answer. But if you didn't recognize it and you put the 36 months over 12, that's fine too. Option number 2, same formula. Same principle too, because we're borrowing the same amount of money. However, the interest rate changed and the length of time changed. So the interest rate converted from a percent to a decimal becomes 0.039. And now we're talking about 48 months over 12. And that equals 3,120. Now again, 48 equals 4 years, so you could have substituted that fraction out for just the number 4. But if you didn't and you did it this way, that's fine. The last question we have to answer, now that we've worked it out, is how much less will she pay? Well, we know that option 1 is better, but we need to figure out how much less she will pay if she chooses to do option 1. You simply take the difference of the two. So you take option 2, you subtract option 1 from it, and the answer is 1,380. So she will save $1,380 by choosing option 1, and she will spend $1,380 more if she chooses option 2. Okay. That concludes simple interest. You guys will find that in the classroom, you have a class worksheet on simple interest to complete. Feel free to use these notes. Feel free to use your notes. Simply complete the assignment and then send it back. Thanks, guys.